The Snohomish River, near Everett, Washington, for 5 years the scene of Cohstrex.
Cohstrex is an acronym that stands for Coherent Structures in Rivers and Estuaries Experiment.
Principal investigator Andy Jessup's goal?
Increase our understanding of how to use remote sensing techniques to measure properties of river flow.
Sensitive video, microwave radar, and infrared sensors capture small differences in surface water temperature and surface ripple patterns, important clues to what's happening below, out of sight.
We're investigating the fundamental physics in the river. And one of the big unknowns in rivers are turbulence physics, so how the river is mixing and what causes that mixing. The river that we're on right now, the Snohomish, we're in a portion that's tidal, so it's actually influenced by the tide every day. At sometimes that when the tide is flooding or rising, the flow of the river can reverse. All right, we're going in. Say you want to control the banks with levees, or you want to build bridges with footings in the river. That's basically what we're investigating, is how structures in the bottom affect the flow.
Anybody who wants to navigate a river would need to know this. You'd like to know where there's hazards to navigation, simply whether it's deep or shallow, so that you can get a vessel in. It's important for the Navy if they need to go into an area where they don't have measurements.
For operations, they need to know how fast the river is flowing and how deep it is, so we're investigating remote sensing techniques to help inform them.
When we do these experiments, we live on the river for several weeks at a time. In the early morning when you wake up and the sun is rising and nobody else is around, it's beautiful, and we certainly do appreciate those moments.
This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.